Day 2 of section 2.4, which is dividing polynomials. So today we're going to look at dividing polynomials using something called synthetic division. For synthetic division, we are using properties of division to create like a more concise way to perform division for a very specific case. So this only works when I have a linear expression in the form of x minus a. So the leading coefficient's 1 and a is the 0 of the divisor. And so in order to divide using synthetic division, what we're first going to do is take our divisor. In this case, it's x minus 3, and we're going to find it 0. So I'm going to set x minus 3 equal to 0 and solve for x. And so doing that, I have to add 3. And so my 0 is equal to 3. That's what's called the a. And so what I do with a is I write that number down. So I'm going to write 3 here, and I'm going to separate it from the dividend using this little box. And then for the dividend, what I'm going to do is take and list out the coefficients. So notice that we are dividing 2x cubed minus 7x squared minus 4. And so that's missing the x term. So we've got a 0x inside the dividend in this model of long division. And so when we write out our coefficients, we're going to include that 0, because if we don't, we'll actually end up with an incorrect solution. So we're listing just the coefficients. So starting with the leading, we have a 2, then a -7, and then a 0, and then a -4. So step 2 is listing those coefficients of the dividend like so. And then with this, the way that we're going to kind of organize our work is I skipped one line, like enough to write another line of numbers. And then underneath that last number, I'm going to put a little box. This box is actually going to hold our remainder. So just another organizational tool there. Our remainder is going to end up inside that box. So for the steps for this process, I have them written out. So the next step that we're doing, so we've already done step 1, which was find the 0 of the divisor, and step 2, which was list out the coefficients of the dividend. We're going to bring down the leading coefficient, which was 2. So we're going to bring down that number 2 and write it underneath the line. So then every time after this, what I'm going to do is multiply a by the number that I wrote below the line. Okay, so for the first number, it's always just the leading coefficient. So my leading coefficient was 2. 2 times 3 is 6. And then step 5, I'm going to add vertically. So I'm going to add -7 plus 6, which gives me -1. And then I'm going to repeat those steps 4 and 5 until I have no numbers left. So meaning until I've added -4 plus something, and then that answer will be my remainder. Okay, so I'm back at having a number below the line. So I'm going to multiply that by a, which was 3. And so -1 times +3 is going to give us -3. And then I'm going to add vertically. So 0 plus -3 gives me -3. And then 3 times -3 gives me -9. And again, I knew this was the last one because I'm going to end up with my remainder. So -4 plus -9 is going to give me -13. And so when we're performing synthetic division, we had to use our placeholders mostly because we've eliminated the variables. So with long division, we can see what's like terms as we go and know that we're lining it up correctly. With synthetic division, because we eliminated the variable altogether from the problem for this process, we have to ensure that we're actually combining like terms as we're doing the steps, which is why those zeros are so important. And so if we think back to if we were dividing this for real with long division, we would have taken x and divided 2x cubed by that number, right? That was our first step, was we would have done 2x cubed divided by x, which would have given us 2x squared. And that's the number that we would have written up here, or the term that we would have written at the top for the first part of our quotient. And so this 2 represents the coefficient on that term. And so what that means is that this 2 is attached to the variable x squared. The reason, or the way that we could know that each time, is that this power here is always 1 less than that power there. Okay, so the degree, I'm going to write us a little note here. So the degree of the quotient is always 1 less than the degree of the dividend. Because the divisor is always linear, which means that it has a degree equal to 1. And so the difference of the degree of the dividend minus the degree of the divisor is really what ends up happening here, right? So if I think about that, this 2x squared is because I'm subtracting 1 from the degree of my dividend when I'm performing that division step. So this will happen every single time. So this coefficient is on a variable with a power 1 less than that of the dividend. So in our case, x squared, because we had an x cubed. And then each of these coefficients go along with the next term. So if I have a negative 1 here, so it's going to be minus 1. And since that was x squared, the next term is going to be x. And then the minus 3 is going to be the constant term. And then we already talked about the negative 13 is the remainder. And so just like with long division, we're going to write that over our divisor, which was the x minus 3 from the given problem, right? So we were dividing by x minus 3. So that means that our answer here, and I'm just going to write it without all my annotations, is 2x squared minus x minus 3 minus 13 over x minus 3. So before we move on to looking at some other properties of division, I want to go back and do an example from our long division notes. Okay, so if we can look at the notes from long division, remember that synthetic division works when your divisor is linear with a leading coefficient of 1. So notice that x plus 3 for this problem was linear with a leading coefficient of 1. So synthetic division is an option here. If we look at the problems on the back, this was linear, but it's not, the leading coefficient is 2, not 1. So synthetic division is not an option for B, nor is it for C, because we had a quadratic divisor. And so what I wanted to show you is how I can do this problem using synthetic instead. So in this little spot over here, rather than all that space that we use for long division, let's organize out synthetic. So synthetic division works where we put the 0 of our divisor separated from the values of our leading coefficient. So if I were to set x plus 3 equal to 0, the way that it works is that the value I use is the opposite sign of what I had here. So in our last problem, we had x minus 3, and we put a positive 3 there. Because we have x plus 3, the 0 is going to be the opposite, negative 3. Our next step is to write out each of our coefficients. So the leading coefficient on this, x cubed, is a 1. Our next coefficient is 5. And then we have 6. And then we have 9. So we write out our leading coefficient, and then each of the ones that follow, because we have x to the third power, x squared, and then x to the first power, and our constant, we didn't have to add any zeros for this problem. So one thing to kind of notice is that whatever this power is here, if you have every term, you should always have one more term than there is the power, because of that x to the 0 that represents the 9. And so that's one way to kind of keep in mind whether you have all of your terms or not. So we're going to bring down the first term. So our leading coefficient is 1. And then we're going to multiply that 1 times negative 3, which gives us negative 3. We're going to add that with 5, which gives us positive 2. And then positive 2 times negative 3 gives us negative 6. Negative 6 plus negative 6 is 0. And then negative 3 times 0 is 0. And 0 plus 9 is 9. So we ended up with the values 1, 2, 0, and 9, performing synthetic division. Remember that when we're looking at what variable goes with the first term, it's always 1 less than the degree of our dividend. So our dividend was cubic, so that means this is squared. So we have a quadratic, and then that would be x, and this would be our constant. And so this gives us 1x squared plus 2x plus 0 plus 9 over our divisor, x plus 3. And so notice that this is the same as the answer that we got with long division. We just use a lot less space. So synthetic division is helpful for situations where we are allowed to use it. So now let's look at some other properties of division with polynomials and relationships that we can find within those. So the problem for example 3 is asking us to find out how the value of p of a is related to the remainder of p of x divided by x minus a. So when p of x is 2x cubed minus 7x squared minus 4, which is our dividend from the previous problem. And then a is 3 was our a from the previous problem. So what they're asking us to do is to take 3 and plug it into p of x. So they want us to find p of 3, where p of x is 2 times x cubed minus 7 times x squared minus 4. And then we're going to plug in that value 3 for a. So if we do that, 2 times 3 cubed is 2 times 27, minus 7 times 3 squared is 9, minus 4. So this is giving us 2 times 27 is 54. 7 times 9 is 63. And then minus 4. So 54 minus 63 is negative 9. And then negative 9 minus 4 is negative 13. And so notice that negative 13 was our remainder from that problem before. So what we can see here is that P of 3 is negative 13. So P of 3 is negative 13, which is the remainder of P of x divided by x minus that 3. Okay, so what we saw here is that if I perform synthetic division, so if I divide using a of 3 in the equation 2x cubed minus 7x squared minus 4, my remainder is negative 13. And if I simply plug 3 into P of x, so into 2x cubed minus 7x squared minus 4, I get a value of negative 13. So evaluating a function at a is the same as the remainder. So that is what we're calling the remainder theorem. So the remainder theorem states that if a polynomial P of x is divided by x minus a, then the remainder is P of a. And so what we can do with different problems is, if they're asking us to evaluate something and the problem is complicated, sometimes synthetic division is faster. And so rather than plugging the number in, we could perform synthetic division, which keeps the numbers a little bit smaller. Because we didn't have a number like 54 or 63 when we were performing synthetic division. Everything was under 10 until we got the negative 13. And so that's when the remainder theorem can come in handy. So for example, 4, we're looking at the population of tortoises on an island that's modeled by a function where x is the number of years since 2015. They want us to use the remainder theorem to estimate the population. So what we're going to do is take, and instead of evaluating P of x and doing something where we're going to get a large value because we're doing a cube times a squared and we're adding up all these numbers that are going to be large, we can use synthetic division to help us do that a little bit more quickly. And so what we want to do here is first identify what A is. And so A for this problem is kind of given to us indirectly. So when we're given like a P of A problem, like in example 3, they're going to give us the value of A. Notice it was the same sign as the A here, where when we were dividing, we had to find the 0, which changed it. So they gave us this x minus 3. We ended up using a 3 here. For these types of problems, because they're giving us values, we're going to use A directly. And so they want us to estimate the population in 2023, where X values are the number of years since 2015. So that means we're going to subtract 2015 from that. And so 2023 minus 2015 tells us that we're going to use an A value of 8. So we're going to perform synthetic division with an 8 over here. And our function. So our function, if we look at our coefficients, so we have a -1, and that's cubic, and then 6 is quadratic, 12 is linear, 325 is constant. So we have 4 terms with a cubic, which remember is our kind of trick to make sure that we have all the terms we need. So let's list out our coefficients. So -1, then 6, then 12, then 325. And we're going to skip a line so that we can draw numbers underneath there and then include a box for our remainder. Remember that our remainder is actually going to give us what P of 8 equals. So the remainder theorem helps us figure out what P of 8 is, which will tell us the population of the tortoises in the year 2023. So we're going to bring down the leading coefficient of -1, and then every number that we write underneath, we're going to multiply by the number in the box. So 8 times -1 is -8. 6 plus -8 is -2. 8 times -2 is -16. 12 plus negative 16 is negative 4. 8 times negative 4 is negative 32. And then 325 plus negative 32 is 293. So that means that P of 8 is 293, which tells us that there will be about 293 tortoises in 2023. So the remainder theorem helps us with evaluating functions when we might have like a lot of places to plug in x or just large values. So an extension of the remainder theorem is something called the factor theorem. The factor theorem states that the expression x minus a is a factor of the polynomial p of x if and only if p of a is 0. So we know that p of a represents the remainder, so they're saying that the remainder is 0. Remember, because the word factor means that it divides evenly, which means that the remainder is 0. So this should be something that makes sense because we know what a factor is. So for example 5, they want us to use this remainder and factor theorem to determine whether the given binomial is a factor of the polynomial p of x. If it is a factor, they want us to write the polynomial in factored form. So the fact that they want us to do that means, or the fact that they want us to do that, we should use synthetic instead of just evaluating, because if we just evaluate, then we can tell whether it's a factor or not, but we can't write it in factored form. We'd still have to use synthetic division to be able to write the polynomial in factored form. And so I'll show you that as we get into the problem. So if I'm performing synthetic division with this, so I want to divide x to the 4th minus 8x cubed plus 16x squared minus 23x minus 6 by x minus 6. Remember that we start with that divisor x minus 6 and we set it equal to 0. So to do that, we would add 6. So x equals 6, and that's the number that we separate out from the coefficients. One thing to notice is that when we do that, it's always the opposite of the number in the binomial. So whatever our constant was in that binomial, the opposite value is what goes in the box there. Then we're going to write our leading coefficients. So we have a quartic function. Our leading coefficient is 1. That's our x to the 4th term. Our next term is cubic. That has a negative 8. Then we have a quadratic term. So our next coefficient is 16. And a linear term. So our next coefficient is negative 23. And then a constant term. Our last value is negative 6. Remember, our trick is that this has a 4th power. This has 5 terms, so we know that we're not missing anything. If we look at division now, we're going to skip a line, draw a line, give us a little spot for our remainder. And so really what we want here is if this is 0, then it's a factor. If this is not 0, then it's not a factor. So if we bring down our leading coefficient, then multiply 6 times 1, we get 6. Negative 8 times 6 is negative 2. 6 times negative 2 is negative 12. 16 plus negative 12 is positive 4. 4 times negative 6 is positive 24. Sorry, 4 times positive 6 is positive 24. Negative 23 plus positive 24 is 1. 6 times 1 is 6. Negative 6 plus 6 is 0. And so since this value is 0, that means that, yes, so since P of 6 equals 0, so x minus 6 is a factor of P of x. Since it is a factor, they want us to write the polynomial in factored form. Remember that that means that P of x is going to be equal to the x minus 6 that we divided by. Okay, so this is our divisor times our quotient. So our quotient is the values with our leading coefficients, or with our coefficients below the line. So the first term here is going to have a power of 3 because our dividend had a power of 4. The next term is going to be quadratic. Oops. The next term is going to be quadratic, and then linear, and then a constant. So that means that P of x is equal to x minus 6 times 1x cubed minus 2x squared plus 4x plus 1. So what would have happened if we would have just used evaluation and evaluated P of 6? We would have plugged P of 6 in and gotten 0. But that doesn't give us an answer about the factor. That just tells us that it is a factor. So whenever it's asking you to determine if, or to write it in factored form, you should use synthetic division instead of evaluating using the remainder theorem, because you'll have to do it anyway. So for B, we're evaluating P of x at -3. So since we have an x plus 3, I'm just going to bring this B up because I didn't need that much space. So this tells us that for synthetic, since that's a positive 3, we're going to have a -3 that we're using. And then we're going to list out our coefficients, starting with our leading coefficient of 1. That's on an x to the 5th. So we're missing an x to the 4th. So we're going to have a 1, then a 0. Then we have cubic, so -5. Quadratic is 9. Linear is -1. And then our constant is 3. So using synthetic division, we're going to see if this gives us a remainder of 0. So we're going to bring down the 1 and then multiply 1 times -3 and then add 0 plus -3 and then multiply -3 times -3, which is 9. -5 plus 9 is 4. Then 4 times our -3 is -12. -12 plus 9 is -3. -3 times -3 is +9. -1 plus 9 is 8. And then finally 8 times -3 is -24, which if we add 3 gives us a remainder of -21. So what this means is, so since P of -3 doesn't equal 0, so x plus 3 is not a factor of our P of x. And so since it's not a factor, we don't need to identify what this quotient is. All that matters is that that value of the remainder is not 0. So for the assignment today, you're not doing this. There is a worksheet that goes along with this. So it's dividing using synthetic division. So this is like the first example. It really goes in order. Then you're going to verify the remainder theorem and then determine if they're factors. There's a word problem that uses synthetic division and then an explanation for you. On the back of this is the review for your quiz. The quiz is on Wednesday. You will have to do long division from scratch, as well as factoring in the quad form. So when you have like an x to the fourth plus something and you're factoring, if you have that trinomial where you have x to the fourth and then x squared, those are the questions that are not going to be multiple choice on the quiz. So make sure that you're doing all of the problems, because you'll notice that the questions that are on the front, you're still doing those same things on the quiz. So make sure that you're practicing everything within this so that you can be prepared to ask me questions tomorrow about that quiz review. And that's all for this lesson.